Hi, everyone, and welcome to Docker Enterprise Social Distance Learning provided by Mirantis and Stone Door Group. My name is Andrea Alexander with Stone Door Group, and I will be your host for today's event. Today's topic, Docker Tips for Better Productivity, will provide suggestions and recommendations to improve your Docker administration. Our presenters are Bill Mills, Head of Curriculum Development from Mirantis, and Amber Ernst, Docker Accredited Instructor and Certified Associate at the Stone Door Group. For those of you not familiar with Stone Door Group, we are a Mirantis solutions integrator and professional Docker value-added reseller specializing in DevOps transformation. We work with companies of all sizes to implement best practices using Docker and Kubernetes. As part of our service offerings, we have two items that may be of interest to those attending today's session. The first is our Docker CE to EE accelerator engagement. This service provides end-to-end solution for migrating your applications to a secure production environment. In our accelerator engagement, we take care of upgrading to Docker Enterprise Edition and migrating your applications. We do provide all the licensing needed as well as consulting services to ensure you successfully upgrade to EE and have the necessary controls in place. What we have found is that most of our customers have typically implemented to CE but are limited deploying to production due to security constraints. So this package has been very successful engagement with our clients who struggle with the choices and options that Docker provides. A typical engagement will typically take around 2 to 3 weeks from start to finish. The second item I wanted to bring to your attention is our free 5-day trial of Docker EE. This is available on our website at the link provided on your screen. We will be sending this deck out following today's event so that you have access to those details. You can find out more about Stone Door Group and our offerings at stonedoorgroup.com. A few housekeeping items. If you are experiencing audio issues, you may dial in using the toll-free number provided on the screen. That's 1-888-788-0099, and our webinar ID is 742-327-577. If you need assistance, please contact a member of the Stone Door Group technical support team at webinar@stonedoorgroup.com, and our team members are standing by ready to assist. During the presentation, we ask that all participants submit questions through Zoom's Q&A feature. You can find this panel on the bottom of your screen where it says Q&A. And just note, this is different from the chat feature. Instructors are going to collect and respond to questions submitted through Q&A, so make sure you use that panel when you're entering in any questions that you may have. For those interested, we are recording today's event. Following today's presentation, we'll send out an email to all the participants. We'll be sending out links to all participants for access to the event recording and the presentation materials. So if you have any questions, we encourage you to reach out to us at letsdothis@stonedoorgroup.com. Thank you all for joining us. Our Docker Enterprise Social Distance Learning series comprises 4 webinars, and this is the second in our series. Last week, we learned how to upgrade from Docker CE to EE, and today's event provides helpful tips and recommendations to improve your Docker administration. Following today, we'll host 2 more events in the series. We've got May 7th coming up for Docker Tips for Better Security, and that will cover corporate security and regulatory compliance. Our final event in the series will be held May 14th, Kubernetes Tips for Better Productivity, to provide tips on implementing and administering Kubernetes. We hope you'll join us for these events in the coming weeks. Our team will send the series schedule and registration information to participants following today's event. Okay, so as many of you know, we are holding a drawing following each of the webinars. So I just wanted to provide a quick congratulations to those participants from last week's event who were selected to receive promotional gifts. All of our US winners are going to receive a Starbucks gift card and a roll of toilet paper to help you through this pandemic that we've got going on. All of our international winners are going to receive a Stone Door Group t-shirt. So congratulations to our prize winners from last week's event. All right, at this time, I'd like to introduce our presenters. I've got Bill Mills with Mirantis. Bill is the head of curriculum development at Mirantis, where he teaches, develops, and maintains the Docker Enterprise Training Stack. And I also have Amber Ernst with Stone Door Group with us today. Amber is a Docker accredited instructor and certified associate at the Stone Door Group. She is a subject matter expert on both Docker and Kubernetes and teaches all courses in Docker's official training catalog. So Bill and Amber, thank you all for your time today. I'm going to go ahead and pass the session over to you.
Thank you, Andrea. Okay, thank you everybody for joining us today. So I'm just going to jump right into it. So Docker has quickly become one of the front runners when it comes to container management systems, and it is easy to see why, considering what it can do to boost a company's productivity. If you have worked with Docker before, then you know that the same containers that a developer builds and tests are capable of being run in production, on virtual machines, and many other places due to the nature of containerization. So in this presentation, we're going to be covering some useful ways to boost productivity when using Docker. We're also going to take a look at one of the features that's provided by Docker Enterprise. So first, let's get into our Docker images. We want to keep them lightweight. So a Docker file is a set of instructions, and it describes the process of building an image. So it contains files, environment variables, installation steps, relevant commands, and networking details. File context has a huge influence on the build time performance of Docker files. Now, context outlines the specified files that are required to build your container, and the larger the context is, the slower your build can be. Now, this can raise the question for us: what should you do if you have a large build context for your container? The common causes of this are large asset files or additional library files. So once we have our images created, we can easily check the size of them by running our docker image command. So I'm going to show you guys a quick demo where we're going to be showing you a build without using a dockerignore file, and then when we do use a dockerignore file and that size difference. So without dockerignore, what I'm going to be showing you in a moment is, in this example, I have created a Docker file using nano Dockerfile, and I've added in a var opt directory. So this is one that could have a large amount of unneeded log files. I then ran this command docker build, and I tagged it testing. And we're going to take a look at what this current image size is right here. So without using dockerignore, we have 154 megabytes of size taken up in this image. And we want to, of course, reduce this image size. So let's just jump in and show you what this looks like. Now, since we're wanting to reduce that Docker image size, we want to prevent uploading 150 megabytes of logs to avoid uploading passwords or anything like that. Here, let me clear this out for the top. We are going to touch this dockerignore file that I have created. So let me just go into there real quick and show you what that looks like. There we go. So as you can see, I just have a few things in here, like our source docs that I don't want showing, or our tests. This is customizable. You see, you've got some wildcards in there. Okay, and now what I'm going to do is I'm going to touch that file. So going to touch dockerignore. There we go. And then we're going to run the build command again. There we go. I'm going to tag it testing again. Okay, and you can see that it built very quickly because it's already been made. And then we're going to go and we're going to take a look at this image size one more time. Now you can see the difference in our size just from adding this dockerignore. So we went from 154 megabytes to 6.86 megabytes simply by utilizing this file. Now, keeping in the theme of keeping our images small, I also want to show you utilizing multi-stage builds to remove build dependencies. So one issue that we can run into when building in consistent environments is the size of our image. It will get very large. Now, in these types of environments, our images, they include all of the build time dependencies that are not necessary at runtime. So we can utilize multi-stage builds to address this and reduce the size of our image, which means faster build times and fewer resources that are consumed by our system. Now, multi-stage builds, they're very easy to recognize. They have multiple from statements. Every from statement starts a new stage of the build process. And with multi-stage builds, we use the as keyword to reference our build dependencies and create a consistent environment. So in this demo, I'm going to show you a quick example of a multi-stage build. Okay. Let me clear this up to the top for you. Okay, so to save some time, I have already created an image and built it, but I'm going to show it to you guys. So we're just going to nano Dockerfile. And you can see here we have this Alpine 3.5. We're running an APK update. We're making a directory. We're copying this hello.c file into it. And then we're running a GCC compiler and we're running this application, correct? Just a quick rundown there. So it's already been built and it's been tagged. So here we go. Let's take a look at the size of the image though. So I've tagged it my app large. And we can see it's 184 megabytes. Now, if we want to be really thorough and confirm that this was successfully built, we could always run a Docker container run. Then just reference it by its name. And you're going to see that hello world. So let's get to the fun part though. Let's update this Docker file and let's remove those build dependencies. Now we're going to do that by going back into our Docker file. Okay, and what I'm going to do is I'm going to be adding this as clause on the first line, and then I'm going to be adding in a second stanza that will be describing our second build stage. Okay, so that as build. See here. Wait just a second, guys. My system wanted to freeze on me there. There we go. Oh. There we go. There. Okay. Now let's build that image one more time. Oh, ah. Ahaha. It's always a simple mistake. Here we go. Okay, now you can see it was a very quick build once more because we've already had this built, right? This time I have tagged it as my small because I want us to see the differences lined up with each other. Now what I did in that stanza is I just removed those other build dependencies, or in this case, that Alpine SDK. Now we can double check that our app is working again as well, but let me show you guys the image first. Okay, so from this, we can see that our original, our large, was 184 megabytes. But when we changed that, and we use that as build with our multi-stage build, we have it down to 4.01. Now, just to be thorough and make sure that this hasn't changed our app and it's working properly, we could do our Docker container, run, and my app small. And there it is, no changes. Okay, so Bill, in your experience, have you run across working with Docker ignore and multi-stage builds?
Well, yeah, once or twice. Why don't you bring your lab platform back? I want to show people a couple of things you can do.
Absolutely.
So first of all, awesome demo. Thank you, Amber. That's really helps us understand the power we can get out of a very simple usage of a multi-stage Docker file. Let's open that Docker file up again. So remember what Amber just showed you. That hello world image went from 184 megabytes to 4 megabytes by using this multi-stage build. Of course, most of those savings came from not having that compiler, not having GCC and your Alpine software developer kit installed in your final 4 megabyte image. So, I mean, not only does that solve the problem that it's totally absurd to need 184 megabytes to do hello world, it's also a major security benefit as well, right? Never, ever, ever would we ever send a compiler or a software developer kit to our production servers. If you ran a container in production with compilers installed in it and somebody compromised that container, well, now they've got a fully featured C compiler that they can do anything they want with on your production servers. disaster, right? So even this very simple application has not only made your images much smaller, but much more secure as well. That said, the example that Amber is showing us is pointing to a bigger pattern here. Look at what we have in these two paragraphs in this Docker file. The first one, like I said, has a software developer kit and your compilers in it, and we're using to build our source code into our executable. And then the other one, the other image after the second from command, just has the executable, just has the bare minimum amount of stuff we need to run our program. Now, what does that sound like? Right? Remember, these two images are really, an image is just a file system that we want to run our containerized processes in. So what does this sound like? We've got two different file systems. One file system for building our application and one file system for running our application. Think about it for a second, and that sounds like a very simple continuous integration chain. Never mind containers for a second, right? Think about CI before we ever started doing containers. That's exactly what a CI pipeline is, right? You've got one environment, like your build environment, for building all your software. Then you might have another environment or series of environments for testing your software. And then finally, you'll have your staging server, or maybe your production server, where you're actually going to run this software, each with a different file system, right? The build servers will be the ones that have the compilers installed in it, just like this first image, and the first paragraph here is the one that has the compilers installed in it. Your testing servers will have all your testing rigs in it, right? Your tests, your testing infrastructure, that kind of stuff. And then your staging and production servers will just have, the bare minimum amount of stuff you need to run that software in production. The trouble with traditional CI pipelines, though, is that every piece of software is different. Every software you want to put through CI might need different compilers, different software developer kits, different test rigs, and different dependencies once you make it to staging and production. Therefore, we often find ourselves making completely separate pipelines to separate these dependencies for our different pieces of software that we want to put through CI. What multi-stage builds and containerization allows us to do is radically simplify our CI pipelines, because now instead of installing all those compilers and test rigs and whatever on our CI servers, our CI servers now only need one thing installed on them, Docker, right? They just need to be able to run containers, maybe an orchestrator on top of that. Then all of your application build dependencies, test dependencies, and run dependencies live inside the container. So we no longer have to have separate isolated CI pipelines for separate software. We just have one CI pipeline where all the heterogeneity, all the idiosyncrasies between our applications are captured in the container as expressed in a multi-stage build, much like the one Amber has here.
Yes. So well put. Okay. Thanks for that input, Bill. Okay, so I've got a quick one to show y'all here. Docker's CLI syntax, this is very plentiful. It continues to expand. We add in new commands and options, and this, of course, can make it difficult to recall every possible command, right? We're not dictionaries. Now, this is where command completion for your terminal comes into play. So command completion is a plugin that's available for your terminal, and it gives you autocomplete options by hitting tab. So the Docker team has this prepared for Docker, Docker machines, and Docker Compose for both Bash and the ZSH shell. Now, just some installation, if you're doing this locally on your Mac, you're going to go through these steps, but we also have this link for complete installation options that are available. So I highly suggest command completion and following this link and playing with that. Now, I already have mine downloaded, so let me go ahead and just show it to you. Okay. There we go. Now, with mine, I just want to show you, two things that we can do with command completion here, right? Really nice and simple, just because this is a demo. So if I was to type in Docker IM and I was to tab, we're going to see this auto completion, image, images, import, right? if we wanted to go a little further than that and say we want to just look at images with auto-completion, there we go. There. I was a little too impatient. So it's going to list off all of the images that we have available. So this can save a little bit of time, obviously, where you don't have to hunt down everything or type in all of these commands. When we're developing something, we don't always have that kind of time. We want to save it for other things. Okay, so that leads us into the next section, and that's on networking tricks. Now, I want to make sure we have enough time to cover this. So when it comes to networking, Docker has this internal pool of IPs that it uses for a container's IP address. These are invisible to the outside by default, and they're accessible via bridge interfaces. So there are going to be times that you find yourself wanting to create a new container and connect it to a network stack that is already in existence. Now, I want to show you guys how to use a host network stack. So we would be running this command, docker run --net equals host, with the rest of the information. And by running this command, we're giving our new container the ability to attach the same network interface as the Docker host. Now, generally speaking, this is only needed when you're running programs with very specific, unusual network needs, or if you're working with testing. This command allows reusing the host network stack, and I really want to emphasize this, it is considered insecure. So let's say that we have a situation where we have an Nginx host and it's running inside of a Docker container, and a MySQL is running on localhost, and we want to connect MySQL from within Nginx. Since MySQL is running on localhost, the port is not exposed to the outside world. So you could be running the following command to share the network stack with the Docker host, and from the container's point of view, it would refer to the Docker host. So in this situation, just remember that any port opened in your Docker container would be opened in the Docker host. Now, I want to just show this to you guys though, right? Now, after Docker installation, just a refresher here, we have 3 networks by default, right? We can see this if we run our Docker network ls, okay? Now, Docker creates a bridge named Docker 0 by default. Both the Docker host and the Docker containers have an IP address on that bridge, on that Docker host, right? So let's look at, just typing in sudo IP addr show docker 0, just to see that output, right? So we can see my Docker host has this IP address of 172.17.0.1 on our Docker network 0 interface. Okay. If we were to start a new container and get a shell on it, real quick process here. Okay, and we were to, within this container now, type this IPP ADR show ETH0, we could discover how that main network interface was set up, right? Or we could just type in route. Okay, see our routing table instead. Now, on to the main event. Let me exit out of that. We can alternatively run a Docker container with our network settings set to host. So our container will share that network stack with the Docker host, and from that container point of view, or that local point of view, it's going to refer to the Docker host. Now, let's see how this looks in host mode. So let's run a container in host mode. Let me just clear this at the top for you. Okay. So we can see our information here. Now, if we were to look at the IP configuration on the Docker host, let's just do, there we go. There we go. Now, what I'm wanting to highlight here is that both the Docker host and the Docker container, they share the exact same network interface. So they behave as if they are the same IP address. It's the main point of that. Now, we have another option in this when it comes to networking to use another container's network stack. So if we ran this command instead, it would attach a new container to the same network interface as the other container. So you could specify that target container by ID or by name. Bill, have you worked with this or have you run across this use outside of testing?
I've seen people do it, and then I always slap their wrist whenever they do, for exactly the reason that you just pointed out, Amber. So in Amber's last demo, she showed you that that container, when it's running with networking host mode, can see the entire network stack of that host. Now, you tell me what happens if somebody compromises that container. Right? Now, containers are meant to be as secure as possible, but that doesn't mean you assume that no one's ever going to break into them. If someone breaks into that container with a host mode networking enabled for it, now they can sniff all the traffic on that host networks. Disaster, right? Something we absolutely want to avoid. The good news is that it's very, very rare for host mode networking to really be necessary at all. But Docker natively, as well as Swarm, as well as Kubernetes, all provide really rich inter-container networking features that make it really usually unnecessary to use host mode networking. So like, consider Amber's example from a minute ago. I think, what was it? It was Nginx pointing at an SQL database, for example. Okay, fine. So let's take both of those and put them in containers. Those two containers, the Nginx container and your SQL container, can look each other up by container name on a custom Linux bridge. So just for the simplest possible networking between those two components, make yourself a custom Docker network on your host, create those two containers, plug them into the same network, and they can DNS resolve each other by container name. Now, if you don't want to rely on layer 2 networks like a Linux bridge, and you'd rather orchestrate your SQL and your Nginx containers, as well you should for high availability, and you're doing this on Swarm or Kubernetes, you could create those two objects as services for deployments on Swarm and Kubernetes respectively. And the same thing is still true. The name of the service providing ingress to those objects is DNS resolvable. So it's really not necessary for those two components to communicate with each other directly across the host networking stack, right? They can go across your orchestrator's networking layer just fine. So in almost all cases, that's what I encourage people to do rather than using host mode networking. In terms of two containers sharing the same network stack, let's take a step back and look under the hood a little bit about what's actually happening here when two containers share a network stack. It's actually the same thing as when a container shares your host networking stack. Remember that containers are really just a bunch of Linux namespaces, right? Kernel namespaces. One of those kernel namespaces that containers take advantage of is your networking kernel namespace that gives a unique set of ports and networking rules and all that kind of stuff for each individual container, each with its own private networking kernel namespace. Host mode networking takes your container and shares the networking namespace with your host. The other feature that Amber showed you, where you have two containers sharing a networking stack, really those two containers are sharing a networking kernel namespace. Fine, it works. You can do that so that those two containers can communicate across localhost. But think about that for a second. What does that sound like? Two containers sharing a networking namespace that can communicate across localhost. That's a Kubernetes pod. That's exactly a Kubernetes pod. So if you find yourself doing that in Docker or without Kubernetes, trying to share networking namespaces between containers, you might seriously want to start thinking about migrating to Kubernetes, because Kubernetes does that a lot more easily and a lot more scalably. So the example that Amber showed you had you taking one container, right, like one Nginx container, for example, and sharing a network namespace with one other container, one SQL container, for example. You can do that on the individual container level. There is no good, convenient way to do that with two Swarm services. So like if you've got a bunch of replicas on Swarm of your Nginx containers and a bunch of replicas of your SQL containers, there's no way to put them together nicely into pairs sharing network namespaces. Creating them as pods, on the other hand, much simpler, much easier to do on Kubernetes. So think about a migration to Kube once you start sharing network namespaces between your containers.
Yes, absolutely. Just another reason that I would suggest, moving from Community Edition to Enterprise. Okay, speaking of Enterprise, one of these featured tools that comes with Docker Enterprise is our Universal Control Plane, our UCP. So this has an API. It has a REST API available using HTTPS. So it enables programmatic access to Swarm resources that are managed by UCP. And the UCP exposes the full Docker Engine API, making it possible to extend your existing code with the UCP features. So it is secured with RBAC policies to ensure that only those that are authorized to make changes or deploy applications to Docker are the ones that can. It's also very easy to access as well. So let me just show that to you. So once we're in our UCP, all we have to do is click down on our live API to access it. So I've already got one pulled up here. So if we're to tour this, take a quick tour. Our system manages Swarm resources by using collections. You can access these by selecting this collection endpoint. So our collections, right? Now, say that we're a developer. We want to run tests before deploying an application, but rather than build testing into an environment, we could just jump straight into the live API. Let me just go to services here. Oh. Hold on. Ah, here we go. I thought I had it up. Perfect. So in our services here, what we can do is say we want to test something, right? We could change our parameters in here and we could click try it out. Now, what's great about this is it's going to run that command. It's going to show the output and it's going to also show a corresponding HTTP status code. So for example, if we got 400, right, we would know we had a bad parameter that was there. Now, if the testing shows that it is successful and it doesn't produce any errors, we could actually copy this and we could put it in to our code, just straight into it. Now, we also have administrative options here. There's an accounts endpoint that's very popular when it comes to performing operations in bulk user accounts. So the possibilities are endless here. What's your take on the API, Bill?
So go ahead and open up another one of those API specifications, the one you were just looking at a second ago, for example.
Yeah, here we go.
So in each of these, it explains to you what sort of JSON payload, that big blob right at the top there, you need to provide in order to successfully hit that API endpoint and define something. Look at that, it's huge, right? Nobody wants to type all that out. Right? So when are you actually going to use these API endpoints, you're going to use it in automation tools. Remember that CI pipeline I was talking about a while ago? It's not a human that's going to hit these API endpoints. It's going to be Jenkins or GitLab or whatever your CI agent is for hitting these things. It's going to be able to conveniently and accurately generate all these objects. So fine, we want our CI agent to be able to hit our API as part of our CI pipelines. But how are we going to do that securely? How do we provision reasonable credentials for our Jenkins or GitLab or whatever to hit this API? So remember that the role-based access control imposed and defined in UCP gets applied to these API endpoints as well. It doesn't just get applied to things you click on in UCP. It doesn't just get applied to the CLI. It also gets applied to this API. So Amber, let's go back to the UCP dashboard for a second. Let's set up a CI pipeline right now, or at least the RBAC for it. So let's make a user real quick under access control. Let's make Jenkins. So I would usually set up a user specially dedicated for my CI agent. So let's call them, okay, it can be Bill, sure.
Bill, yeah.
Okay, cool, here I am. I am apparently your CI agent now. And now I would think a little bit about what I want that CI agent to do. And to do so, I would define a role for them. So if we click on roles there for me, let's just make a swarm role, just something straightforward right now. Let's go create. So under here, if I click on, let's name it like CI responsibilities. And let's imagine that we're doing a really simple CI chain. It's just a build server. Let's just make a build server here. So under operations, I might say, all right, I don't want to give this Bill character, the keys to the kingdom, permission to do anything he wants on my cluster. He's just supposed to be a build server. So let's give him, say, image operations. So if we click on that little drop down, the third one there, yeah. So we can give him all image operations there, or we can expand it there and just give him the ones he needs. Looks like he's probably going to need most, if not all of those. He's supposed to be a build server, building and pushing images. So that seems reasonable. Let's save that. And then that is the custom role, CI responsibilities, that I would give.
Uh-oh. Here we go. Sorry about that, Bill. It seems like for a second, everything just froze. Wonderful. Okay. Can you hear me?
I sure can. Did you get the last of what I said there, or did I drop out?
I heard CI responsibilities and everything froze out. Have to love pandemic internet connectivity.
Excellent. Everybody's on the internet all at once. That's exactly how it was designed. Yeah, no, I was just saying that, yeah, by what we set up here, we can control that CI agent's access to the API and give them just the level of access that they need with this custom role that applies to the API endpoints you were just showing.
Yes, exactly. Okay. There we go. Now that's just the tip of the iceberg when it comes to the API and everything you can do with the UCP. I mean, there is so much, it's a powerhouse in what it is capable of doing. So quick reminder about us. We are a Mirantis Solutions integrator and professional Docker value-added reseller, and we specialize in DevOps transformation. So if you joined us today because you're working with Docker and you want to take it to the next level, we have Docker Accelerator. It's a service that provides this end-to-end solution for migrating your applications to a secure production environment. In this engagement, we take care of upgrading Docker Enterprise Edition, migrating your applications, and we provide all the licensing needed, as well as consulting services to ensure that you successfully upgrade and have the necessary controls in place. So in other words, we get you where you want to be. Now, if you're ready to roll up your sleeves and get to it, we offer 2 ways to request a free trial. You could either click on this, talk to us, fill out a form, and we'll get you a free trial, or you could just go, if you already have your environment set up, run this command. Try it out for free. Now on to a few minutes of Q&A. Let's see here. Let's pull up some of our questions. Okay.
All right, Joshua here asks, how would the image build role permission be used? I would think CI servers, build servers rather, would build locally and then push the image to DTR. Joshua, you could do. So imagine if you were running Jenkins just sort of natively on a build server, then yeah, that's not what you're suggesting is not unreasonable. You could do exactly that. Build locally, push to DTR. But what if you're running Jenkins in a container? In that case, where is Jenkins running exactly? And does it have access to the build server, right? No, it doesn't, unless you specifically grant it access through its client bundle that you provision permissions to do builds with through that image build role permissions that we were showing you. So really it becomes most useful when you containerize your CI agent. And of course you're going to containerize everything. So that's why I like to illustrate that.
Oh, yes. Let's see here. The other one we have, David, as asking if Docker training can be purchased for individuals or is it for group only? Yes, you can purchase it as an individual and join us in class if you want to learn this in depth. Yeah. Okay, let's see. Do we have any other questions?
There were some in the answered stack that I was talking about
Okay.
before, like while the lecture was proceeding.
Oh, wonderful.
There were some good ones here. Okay, anonymous attendee asks, when we were talking about our multi-stage Docker file, said the second block of the Docker file did not have a maker command, unlike the first one, even though the folder app bin is still used. So in a Docker file, when you go ahead and specify a path for a file that doesn't exist inside your container image, that path will get created during the build process automatically. That said, I usually encourage people to explicitly specify when they're making paths inside their container images, just so that there's no magic in the build process, right? Just so that it's very explicit and easy to read from the Docker file what exactly is happening in that build process. So short answer is it works without specifying it, but don't do that, right? Specify things so it's easy to understand.
Exactly. Yeah. I save a little time for demo purposes, but yes, we want to detail that because the beauty of a Docker file is that if you have someone new joining your team, they can go through and they can see how these images are created. You don't want them left in the dark.
Yeah, it's almost like default documentation for your images, right? If no other docs exist, at least you can look at the Docker file and understand what went in there. Prashanth asks, Docker host, does it work differently on a Mac? Yeah, a little bit. So Amber was showing you earlier how to use the host networking stack from one of your containers. So remember that on Docker for Mac and Docker for Windows, your containers were actually running in a VM. So everything that Amber told you is still true, but it's true from inside the virtual machine that your Mac or your Windows machine is running to run those containers. Now, some stuff like ports for networking and like some paths in your host's file system, like your actual Mac's file system, are exposed inside that virtual machine. So you can get native Linux-like behavior for exposing ports and mounting directories. To see those, click on the little Mobi icon in your Docker for Mac or Docker for Mac or Docker for Windows, and look under Preferences, and there'll be some options there for controlling exposing ports and exposing file system locations on your actual host, not just the virtual machine.
Okay, let's see. We have a couple questions in the Q&A. Yes, we will have a recording of URL that will be sent out to y'all. Okay, and let me go through and find another one in here. Let's see. Ah, yes. Earlier, Paul had asked in the Dockerfiles, is there a difference in where the as statement goes? Because I use that as build from. So yeah, I had to correct it. So we would do that from, and then we would do the as build right after that. And then we'd put in our second part, our second stanza for that new build.
Yeah. If anyone here is familiar with makefiles, you'll find your Docker multi-stage build Dockerfiles kind of start feeling a bit like a makefile after you label all those different build sections. And also when you do Docker image build, there's also a target flag, just like a makefile, if you want to build one of those earlier sections as well. So kind of at a conceptual high level, you can almost think of it a little bit like a makefile, and it's labeled in a similar way.
Yes. See here. Oh, we have some new ones.
Prashanth asks, how can I do Docker Swarm with Docker Desktop on Mac? Simple. Simply type Docker Swarm init, and you will have a swarm spun up right on your host machine. Now, if you're thinking about making like a broader swarm with like lots and lots of workers, you could do things like getting like a VM manager for your Mac where you'll spin up a bunch of extra nodes and join them as workers to your swarm, to your one swarm instance that you get from doing Docker Swarm init. In general, that's often not really necessary. So the real goal of Docker Desktop is to enable that inner loop for developers, right? Writing your code, putting it in a container, and launching it as an orchestrated set of containers on just a single node swarm, just that one master that you get from doing Docker Swarm init. When you want to start seeing behavior and performance across a cluster, really, you're going to want to push that to a testing or a development cluster, right? Rather than just doing it locally on your Mac, right? So Docker for Mac, best suited for developing. Then when you want to see that behavior, push it out to your staging servers, testing servers, whatever it is you use.
Great answer. Let's see here. Let's go ahead and take another, and then I see that a lot of the others probably we can answer with our next slide. So, is any question catching your eye, Bill?
Let's see here. Andy asked, do we have any guidelines for building machine learning or AI containers with GPU support? GPU support is coming to the engine very, very soon, like in our next enterprise release. So stay tuned, and that's going to be available for you shortly.
Wonderful question. Let's see here. Great. Thank you, guys. See, Tony has one here. What is the best practice for container assignment in a swarm to ensure high availability? I'd like to ensure instances are load balanced across different nodes in the swarm to ensure a node failure doesn't take down my application. Great question, Tony. Let's see here. I'm trying to find the best way to answer this. Bill, do you have, maybe you have the shorter answer on this one than I do.
Absolutely. You're going to want to use a system of node labels. So what you can do is take your cluster and group your nodes into different, typically physical availability zones. So like each batch of nodes, say like one rack would be labeled like rack A, another rack would be labeled rack B, etc. Right? Grouped in a way that reflects common outages. And then what you can do is when you create a swarm service, you can specify that the containers for that service must be distributed as evenly as possible across those label values, right? So if you've got like two availability zones, availability zone A and B, and you make a service with 10 replicas, 5 will go to A and 5 will go to B. And hopefully from that, you can understand what I meant by saying like, grouping your nodes by label with common outage patterns. So like, for example, if one entire rack goes down, you don't want to have had all your containers on that one rack, right? You want some of them on some other server rack somewhere else, because those two racks are two sort of independent objects that might go down separately.
Yes.
I mean, I guess the really short answer to your question is yes, and it's label your nodes.
Yeah, label your nodes.
Yeah.
Okay, let's see here. So we have a question from anonymous attendee about understanding the idea of dockerignore and removing compiling environments. Is there a best practice around everything I should ignore or reference architecture? That actually is a wonderful question. At the end of the slide, I have a tie or some links to our Docker documentation. Docker has updated documentation. It's very in-depth, and any questions or reference architecture is going to be showing available on there.
And to give you a very short answer live right now, yes, remove everything. You want as little in your images as possible. Right? So whenever I'm building a new image, I'll make a clean directory, put all the assets that I need in that directory, and make sure that's the only stuff that gets zipped up and put into my image.
Yep, we want to keep them small.
Mm-hmm.
Okay. Let's see here.
Paul asks, Paul's been thinking about moving from Swarm to Kubernetes, and the scenario is that they have single node swarms. Does it make sense to move to Kubernetes? Single node Kubernetes clusters make as much sense as single node swarm clusters. There's no reason to prefer one orchestrator over the other for that use case. So by all means, go for it.
Yeah. Okay. Let me see. Is there one more you want to take before we move over to our next slide?
Go for it, Amber.
Okay. So let's see here. Is there one webinar for basic Docker? Simple question, it actually is going to tie to what we're going to show you here in a minute. Currently, we don't have a webinar for basic Docker, but that's because this is a nice way of putting it. Docker isn't basic, right? So even our fundamentals aren't fundamentals, they're the essentials. And I really would highly suggest taking a class with us so you can get that time and get your hands on a lab environment and get that practice and support you need while learning it. Okay.
Speaking of classes that we can take for our basic Docker training and beyond, Mirantis offers a wide variety of Docker and Kubernetes training courses, principally through our tremendous partners at Stone Door Group. So if you would like Amber to jump on the phone with you and teach you an extended workshop from the basics all the way to our advanced day 2 operations for Kubernetes and for Swarm, that's something we can set up for you. So I think the thing that really sets Mirantis training apart is that this is all developed based on the real world experience of our field teams, our solution architects, and our support teams. So for years and years, Docker and Mirantis has been going out in the field, working with customers just like you to get you bootstrapped on your containerization journey. We don't simply get people set up, though, on those projects. We take all the things that we learn from them, all the problems that other customers like you have had, and build those into our training workshops. Also, in our training workshops, I try to make sure that these workshops are at least 2/3 hands-on by time. So rather than just sitting and listening to us like we did in this short webinar, you're going to get your own lab environment, you're going to get to try all of this at your convenience. Okay? And after you finish those workshops, we've got a series of industry standard certifications that you can take, put on your LinkedIn, and demonstrate your knowledge of containerization in Kubernetes. So on the Docker side of the fence, we've got a learning journey that will enable you from the fundamental, like the very basics of Docker that was asked about in the questions a moment ago, all the way through developing and operating operations, or operating containerized applications rather, at enterprise scale. So this learning journey will take you from knowing nothing at all about containerization to being a master of the Docker enterprise platform. And then on the Kubernetes side of the fence, we've also got a similar series of courses that'll take you from never having touched Kubernetes before to being absolutely fluent in all the critical features of orchestrating containerized applications with Kubernetes, all in these intensive hands-on workshops taught by our colleagues at Stone Door Group.
Great. Thanks, Bill and Amber. Another quick congratulations to the participants from last week's event who were selected from our drawing. Again, all of our US winners are going to receive a Starbucks gift card and a roll of toilet paper. And then our international winners are going to receive a Stone Draw Group t-shirt. And just real quick, thanks again, you guys, to everybody for participating in today's presentation, Docker Tips for Better Productivity. As mentioned earlier, this was the second in our series. We've got a couple more coming up. May 7th, Docker Tips for Better Security, and then May 14th, Kubernetes Tips for Better Productivity. Like today, all events are going to last approximately 1 hour and begin at 9 a.m. PST. You will receive an email with details on registering for these, and we hope you're able to join us. Following today's presentation, we are sending out an email that's going to provide a link to today's recorded session and the presentation materials. Also, at the close of today's event, you're going to see a survey poll, and we ask that you take just a brief minute to answer 4 questions to help us improve our presentations in the future. Thank you again to our presenters, Bill and Amber, as well as all of our participants for taking the time to join us. And again, please feel free to reach out to us at letsdothis@stonedrawgroup.com. Thanks again.